Hi class, this is Dr. O'Connor. In this video I'm going to talk about Gay-Lussac's law. And this is the relationship between temperature and pressure. So what we can say is the pressure is proportional to the Kelvin temperature. Okay? So again, just like with the other gas laws, to make this a mathematical statement, I'm going to need a constant. So what we can say is that pressure over the temperature is equal to a constant K. And because of that, I'm able to relate initial and final conditions. So what we have here is P1 over T1 equal to P2 divided by T2. So think about Gay-Lussac's law and the relationship between pressure and temperature. Think about an aerosol can. And we know that the contents of the can, whether it be some kind of a hairspray or it could be that spray palm oil, it is under some pressure. And you know, we're always told to keep aerosol cans away from a flame. And why is that? Because as the temperature increases, right, so does the pressure. So again, we have that direct relationship between pressure and temperature. Increase the temperature, that pressure is going to increase. It'll increase to the point where if you were to throw an aerosol can into a flame, that can is going to explode. So that is Gay-Lussac's law. And this relationship holds when volume and the amount of gas are held constant. So let's take a look at a little problem here. What is the inside pressure of an aerosol can that had an initial pressure of 4.5 atmospheres at 25 degrees Celsius, and it is heated to 550 degrees Celsius? Obviously the volume in that can, the volume of the can is constant, as is the amount of gas. So we have an initial pressure, P1 is 4.5 atmospheres, and we're asking what is P2, and then we have T1. The initial temperature is 25 degrees Celsius. And of course, we want to know what this is in Kelvin. So we have 298 Kelvin corresponds to 25 degrees. And the temperature is going to increase to 550 degrees Celsius. And again, we'll add 273 to that. And that's going to give us 828 kelvins. Okay, so we're all set. We are ready to go. Let's go ahead and take our equation here. We need to solve for P2. So P2 is going to be equal to P1 times T2 divided by T1. Well, let's just go ahead and plug in. We have 4.5 atmospheres, okay, times T2, which is 828 Kelvin. We're going to divide that by T1, which is 298 Kelvin. And then let me go ahead and do calculation here. And that gives us a pressure of 12.5 or 12 atmospheres. So as we would expect, when we heated up that can, the pressure increased according to Gay-Lussac's law.